Well, hello everyone. Welcome to a new live streaming for the live coding of the Uno platform. So I'll be like every Tuesday, uh, taking a look at development of Uno features and taking a look what's been happening in the Uno platform recently. And in the past few weeks, I've been taking a look at one of the features of the applications that uses um, Uno platform and Roslyn and SkiaSharp, and it's called the Uno SkiaSharp Fiddle project that I published uh, on GitHub, so you can take a look as well. So in following the progress, and this is that application is just about uh, using SkiaSharp and C# inside of a single application and make that work and allow you to use that directly in the browser without having to install anything and test out a few features directly in your browsers. And last week I discussed one interesting feature and problem actually that happened when using the SkiaSharp Fiddle, and it was actually interesting. So the idea is that when I built that WebAssembly project here, it was taking a bit longer than I anticipated. And what I did actually is try to figure out why that happened. And it turns out that there was an issue in the bootstrapper, and it was actually because of the fact that in .NET 5, the number of files that are referenced by a project is very, very large, and number of packages as well, and it makes for a number of calls that were not supposed to happen. And I was able to troubleshoot that. So I'm going to show you that, and just quickly so that you can have an idea of what that means to do that kind of troubleshooting using Skia. So using the bootstrapper, sorry. So when I'm building the application like this, I'm actually going to be doing it directly inside the Uno bootstrapper. So it's probably not using the right one. So let's move to that one. So I think it's that one. Let's see. Just want to be sure. No, I'm not using the right version of the preview. So it's the other one. So there it is. So let's go for the Uno bootstrapper. So what I'm seeing here is what I'm going to be showing you here is to be able to troubleshoot the portion that was causing the trouble. So what I wanted to understand is what happens when I build an application and the runtime is the bootstrapper is not doing the right thing. So I wanted to profile what is really happening when I'm building the application. So I'm taking, for instance, let's say that version of so that's the new bootstrapper. The bootstrapper is the package that allows to make a .NET library to run directly in the browser. And there's all samples that I use to ensure that the bootstrapper is behaving the way it should. So those are tested during the CI, and it allows to validate some features and others that are directly in the application. So just to show you what I mean by that is there's a part of the bootstrapper that runs that's called the packager, and the packager is a piece of the .NET runtime that will soon be integrated in the tooling for .NET 6. And actually will eventually be even greater from that code. That code comes from Mono, and it's not yet used in .NET 6. So what I'm doing here is I'm going to be recording the build itself so that we can take a look at the command that are executed. And let's see. So I'm enabled build logging here. And I'm going to be recording all the calls here. Okay, so let's see here. So now I do have, so when I build this application, for instance, so there's lots of things that are be running. So we can see here that it's building the packager, it's building some other tools, and it's building the sample app itself. And to be able to profile the execution of the specific packager step that's part of the build system, I'm going to be taking a look at the build logs for that. So not that one. And I'm going to go and search for the specific step that is executing with everything here. So we're talking about the build dist step, target actually. And then we're going to be taking a look at all of the steps that are there. And there's one specifically here that runs the packager. So if you press the space button, we can see the whole thing. And what I'm going to be doing is we can see here that so it's running in this folder. It's running the .NET command and it's running the packager here. So what I'm going to do is take all the parameters that are sent to the packager, and I'm going to be adding that to the options, the starter options of that project specifically. So that one is actually something that's part of the whole tooling, but I'm going to be replacing that. So that is all the options for the packager. And then if we want to profile this, then it's very easy and it's pretty powerful. You can do a performance profiler here. So let's do it on the packager itself. And we're going to be running the profiler here. So the idea is that most of those parameters are generated by the environment. So you can see here that it's a release configuration and it's using that application path. It's .NET 5. It's using the runtime folder here. So that's the runtime folder. So all of those are based on the packages that are referenced by my project that I just built here. So that's why you have to run it once and then pick up the changes, and then you can run the project that way. So there it is. So let's run the profiler here, and we can see what happens then. So that's it. It went fast. It actually went faster than the previous builds of the packager, but that was to be expected after the change. But so we can see here that most of the time is spent in Cecil reading modules, and there it is. So let's say we open details and see what's happening in that one. And if we go to driver run, well, actually, let's go to the call tree. And in the call tree, we can do expand to hot path. And we'll see that most of the time is spent opening modules. So all the files that are passed as parameters here, they're loaded up and parsed by the Cecil NuGet package to understand what's inside and get the references. So that's why it takes a bit of time. So there's that time that's spent here, and then driver path, and the change was that I made to enable to improve the performance was to remove inside of there's a resolver, and that resolver was doing file.exists in every folder of every path, in every search path that was provided here, and there are many of those, and it was taking a lot of time to discover all those files. So by just making a change that removes the file.exists and use directly the cached version of that, then it will basically drop down from a minute to a few seconds. So that's the kind of improvement that can happen there when profiling the application that way. So that's pretty nice. So that's a good improvement. So now if we go back to the SkiaSharp Fiddle and we update to the latest version of the Bootstrapper package, we'll be able to see that the time for building is going to drop down significantly, lower than what it was before. And that's going to help to avoid having to wait too much when building the application. So if we go back to the build logging, so that we're going to take a look at the time that is spent building the application. And we're going to see how far we went. So in during that time, so there's still a little bit of time that is spent. Well, actually, a bit of time that is spent doing the linking part. So so that the package is not as big as it can be with all the code that may not be used. So the linker is still going through, and that's something that we're going to change, especially if we're using the interpreter mode. The interpreter doesn't need to have unused code removed. You can just keep it that way. But the problem is that because it's using part of the AOT tooling, it was an implicit step that needs to be run. So the idea would be to remove that linker step so that the build goes faster. I see that there's a question in the chat. So does Uno platform support WebView and WebAssembly? So that's an interesting one. So WebView is, I mean, you're running your app inside of a WebView. So that's the base idea. So it's already a web client. So that means that if you want to have access to the web content, well, you basically have two things. So we have not implemented the WebView for now for multiple reasons, but the main one is that the main reason the WebView is used most of the time is to navigate to another site. And the problem that is when you're inside of a browser, the security restrictions around navigating into another website instead of an iframe or something else make it very difficult for the hosting application to communicate with that website. So in that iframe, so it makes it a bit complicated. So the best thing for you to do is let us know what you want to do with that web view. And most of the time, what people want when they're asking for a web view is to actually integrate with another type of tooling. So what you can do is go to the platform.uno and go to the documentation, and we have a set of articles that have been written by Carl de Billy, which talk about embedding existing JavaScript component into Uno WebAssembly. So for instance, if you want to integrate with 3.js, or if you want to integrate a PDF viewer, or if you want to integrate anything that does, that comes from JavaScript, from the JavaScript world, you can integrate that using that article. I'm going to paste that in the chat so that it's easier to read. So it's in the chat for Twitch. If you're on YouTube, you're going to be seeing it through the video. So that's the base answer for the web view. So it's not as easy as it looks with regards to security sandbox related to the use of other websites because of the browser. So the build is done, and I don't know if you remember, but last time it was around 200 seconds. So now we're down to about a minute. Which is pretty nice, and it avoids waiting too much when we're building the application. So let's run the application and let's take a look at what we're having now. So the application is running properly, and if we compile and run, so yeah, so that is run. So the build actually worked, and now we have to resize. We had to resize, but now it's not working anymore. So let's see if there's something else that we need. If we compile, nothing happens. Okay, so we need to troubleshoot a little bit more to see what's happening there. Let's restart the app to see what is happening. So I click the compile button. Oh, nothing happened. I remember now. I think to troubleshoot the performance issue, I think I changed most of the content. I think I commented everything out. So I probably just remove the modifications that I made, and that's probably why there was nothing happening. Okay, so let's start again. So I probably changed a few other things here that will need to be removed. I think I removed a few packages. Yes, I removed this, and I removed SkiaSharp as well. Okay. So related to that change that I made last week with regards to performance, Someone said that we're probably going to be jumping between the two, depending on the type of the build performance that happens between the two. That said, that since that update, there's an issue when building the application when using Entity Framework Core, and where it should be working, and it's not. So it's something that we'll probably take a look. So the idea is 2.0.180 breaks EF Core. So people have been using EF Core in .NET 5. So I'm not sure exactly for what, but we'll try to find that one out. So there's a repro here. So we'll be taking a look at that repro and see what that one does. Okay, so the SkiaSharp Fiddle is probably about to be built, and we're going to be taking a look and see if that works properly. So one of the things that happened when we were building this application is that all the files that we're having here, they're all flagged as embedded resources. So what that means is that when the application starts up, it has to download the whole package. So the Uno SkiaSharp.fiddle, Uno SkiaSharp Fiddle that was on the DLL is containing all those DLL as DLLs as embedded resources. So that means that the application needs to download the whole package up front, and it's too heavy, so it makes for a bad experience. So what we're going to change is we're going to use an API that is available as part of the Windows as part of WinRT, which is called let's go to the documentation, the Uno platform documentation. It's going to be easier. I think I added that one here. There's a Windows storage somewhere. There it is. So you got Windows.storage, and there's an API that's called storagefile.getFile from URI async. And what that file does, what that API does, is that it basically enables an application to get files from the site it's hosted on, but asynchronously. So the application doesn't have it to start with. So let's see if that application works properly this time. Yes, it does. Okay, so I've got my blue here that's happening. So there's an exception here. I don't know what that means. Unpaint surface is, oh yeah, okay, so it's null. So there was no check for that one. Probably it should be enabling null references, so that error goes away. So let's see if I change that to red, for instance. So it gets compiled, and if I refresh, I get some red. So that's good. So that's what we wanted here. It's the proper behavior. So probably should be changing that when the compilation's done. We can actually call the paint once so that we just get the result right away. So let's just do that. And let's fix also that null reference that's happening at the top. So paint may be null. Actually, let's change that. Let's not change that and change it that way. And we're going to be enabling nullable completely for the app and see where that goes. So let's go here. Let's just enable nullable completely and see. Okay, so CodeLens is not having a fun time. Probably the preview. I think I've had that last week when I tried out 1610. So let's do this. So what's happening now? So I have, so UWP is not going to say anything for now because it's not enabled there. But this one may probably start saying that there are errors when building because this is supposed to be null and we're trying to use it without initializing it properly. Okay, so sorry. So it's not true, it's enable. So let's do enable. So, okay, at least the errors are good, so that's pretty nice. Okay, so nullable references are now enabled, so this should fail. So paint is not null here. So let's see if I if I get that properly. Probably should be enabling that as errors so that it's helping there. Okay, so we got that not null here. It's probably, so that thing is not useful. And we get converting null literal to non-null. So that one may be null. And that one is compiler here. So get manifest resource string may be null, but in here it may not be null. So that's another good change. So let's just say that for now we're just gonna take that and we can't really do that. So no, we can't do that because if we don't return, it's not gonna work. It's not gonna work. So if it's null, then we're gonna fail. Let's do for invalid operation exception. Okay, so for some reason for this solution, IntelliSense is completely broken. So I'm probably going to be closing that solution, go back to 69 because it's not particularly efficient for doing all this. Let's go back to the other one. Okay, so the build doesn't want to stop. So if you want to stop the build forcibly, let's go back to here and kill MS build. So I reported that issue, the fact that Visual Studio stays frozen at the end of a build. Unfortunately, the tech support on the other end didn't get did not get the crash dump, so probably gonna have to rebuild that. Oh no, that's the open the incorrect one. So it's gonna be the even one. Okay, so let's see if it's a little bit better. So this is 16.9 preview, so close to the preview that's so close to the 16.1 that's available publicly. Nope, I didn't open the right one. I opened Bootstrap, and that's not what I wanted to open. SkiaSharp Fiddle. Okay. So now I have my compiler here. So the error was throw invalid operation exception. Unable to open F for now. We're going to keep it that way. And metadata reference, so that's expected because we're not on WASM. Okay, so that's it. That's it for now. So we have the create from stream, and if it's null, we can fail. So that's one of the good catches of running with. No, it still fails. Interesting. Okay. Brokered connection for. Okay, so it does the same thing. Probably it's IntelliSense that doesn't like what we're doing. Okay, so in here it was invoke if there's no content, and then what we want to do as well is refresh the surface once we have a paint method, so we don't need to resize anything. So to do that, we can go to the Skia canvas here. We have to give it a name. So let's call it Skia canvas. And then let's call invalidate on it. I'm going to keep it open because it just pushes down the UI. That's quite annoying. Okay, so in here I need, so it's available for WASM, interestingly. So okay, so it's not giving me it's not giving me the IntelliSense because for some reason it's failing on the other end. So let's go find the SK XAML canvas. And let's go to the definition of that. And there's a invalidate method here that we can call to invalidate the canvas. And I will make it for an update for the surface here. So we're going to get the result right away. Okay, so that's it for that. And we're going to try out. So let's go and build that one and see if we can do something else. So with regards to the SQLite in memory, let's go take a look and see if we can have something of interest there. Let's do this here. So what do we have here? Just a simple WASM project. So that's pretty nice. It's a simple demo. So let's go and open that. So we're going to be taking a look at why that fails at runtime. It looks like we're probably changing something that that the runtime is expecting or something. So we'll be seeing if there's something that we can change there. Okay, so let's take a look at that solution that we have here. What do we have here? So it's a .NET 5 interpreter, no linker, no compression. Okay. So let's see what that does. And see, so that we can close. It's not very useful at this point. So SkiaSharp is still building. And see what this one does. Okay, so it's a small application that loads up some content from a URL. So it's a blog entry, save changes. Probably doing it in some in-memory database, I think. Yeah, that's likely to be an in-memory database. Let's see. We have use in-memory database. Okay, so it's an in-memory database, and that one fails. Okay, so let's take a look at what we have here. Okay, so the application is starting up. If we compile, we have some blue. Okay, so that's pretty nice. So we have our blue here, so it's updated right away. And if I do that again, it compiles pretty quickly. It's quite amazing. I mean, Roslyn is just parsing all this and updating. That's quite fast. I'm impressed. I mean, the .NET 5 updates with the interpreter and the compatibility of all those things that are running in the compiler. Having that running in the browser is pretty amazing. So let's go take a look at the SkiaSharp and see if we can grab some other change that we had there. So there was a sample and see if more actually do work. So there's just shared here samples. Let's take the gradient one, for instance. Is that one running? So there's a canvas and paint. Is there some? No, there's pretty much nothing here. So we can probably take all that and paste it in our sample here. And it's using surface. So it expects a canvas somewhere. Okay, so I need to create a canvas here. So that text box is pretty ugly. We're gonna have to change that. Surface, canvas. Let's compile that. There it is. Okay, awesome. So this is running pretty well. So we can see that it updates rapidly. And if I resize, the image is actually redrawn every time. So that's pretty cool. Okay. So the experience is not that nice. So we're probably gonna have to integrate something else there, so that we can have the a better IDE here. So in better IntelliSense and a better editor, and then all the compilation errors that should happen maybe at the bottom, so that we know when something's not compiling properly. And that's that. Okay, so I was talking about downloading files from the outside. So let's go back to the other SQL in memory and see what's happening here. So if I build this and I run, what happens? Okay, so it fails because that's not clear. So the type initializer says queryable methods has more than one matching element. So it's doing something with regards to, so it's load data first or default. It says there's more than one matching element. Load data here. So that would be the deserialization, maybe? Is it the deserialization? No, it's the first or default to entity framework. Okay, so that's not that one. First or default is there first. So that would be this one. So this one fails for some reason because there's something that is different from. Okay, so the idea is that this is not working with the latest build of Uno, of the Bootstrapper, but it's working with previous versions. So what we can do is try to determine if something is significantly different between those two versions. So what we're going to do is take the output of the build, so the dist folder. Just going to copy it here. Let's call it dist file, and we're going to be rebuilding that with the latest Bootstrapper, not the latest, but the previous Bootstrapper, so that we just ensure that we know why it's failing. Let's go for that one, for instance. Previous one that. Okay, so let's rebuild this and see where that goes. Okay, so it's downloading a different version of the runtime, which is fine. So I hope this is not a change in .NET 6. That could be a runtime change between the two that caused that to break. It may not be the Bootstrapper itself that does that. So we're going to take a look at what we can change and kind of cross use multiple versions of the runtime when we're doing this. Okay, so if we run that application, does it fail this time? No, it does not. Okay, so we can see here that it does not fail, which is good. So that means that there's actually a difference between the two. So now, is it something that fails because of a .NET difference, or does it fail because of a change that was made in the Bootstrapper that makes the rest fail differently? Okay. So let's do this. I'm a bit puzzled here. No, okay, that's good. So we get this works. Okay, so I'm going to be using another tool that compares folders. So let's do this. We merge. So let's compare folders. That one with that one. Probably doesn't like the quotes at the beginning and the end. Okay, let's compare. Okay, so that is different, but it's expected. Okay, so the packages folders are different because the runtimes are different. So what we're going to do is we're going to remove the names here, so we can compare the names in the same way. So that is going to be package. Oops. Okay, so it's package here, and same for this one. So the hash here is to be compliant with CDNs, so that if you fetch a new version of the index.html, it will always go to the right version if the CDN provides both versions. So that's one of the ways to ensure that we don't have discrepancies in terms of files that are being fetched, because the whole package has to be exactly the right way. If it's not, then the application may behave incorrectly. Okay, so let's refresh this. Okay, so in the package we have differences there. So the number of files, So we have the core lib that's different here, but I'm not sure if it's going to help that much. Okay, and in the manage folder, we have files that are different. So all the files are there. So if all the files are there and they're not different, so that means that it could be a runtime error. So to validate this, we're going to be doing a trick, which is we're going to go back to the original version of the runtime of the bootstrapper, and we're going to use a previous version of the runtime. So to do this, one of the ways is to use a previous version of the package. So let's say if we go to the temp folder, well, actually let's do it that way. I'm going to show you where that file comes from. So if you go to the bootstrapper, there's a constant.cs file that contains the default values for most of the things that are used by the bootstrapper. So for instance, so let's open the solution. Sorry for the dark theme. I think it opened the wrong version of the wrong version of the tooling. But anyways, so we go to the bootstrapper here, and there's a constant.cs, and there's a path to the runtime version here. So it's in the default.NET Runtime SDK URL. So what we can change is go back to another version, so we can go back at least 1 or 2 versions. But let's use the same version that we had when running the application. So the one that worked, actually we can't see it here. So let's go back to let's go back versions. Gotta be easier that way. So let's go back versions. So I did a few changes here. So let's go back 1 version. So if we take a look at the changes from that one, we can see that the URL for the bootstrapper has changed. So what we can do is just download that file, and we're going to be referencing that file as part of the build. So to do that, there's a special property that you can change that will indicate to the bootstrapper use that specific version of the runtime and not the one that's bundled by default. So that property is located here. It's called netcore wasm SDK URI. It's in the documentation as well, but you can find it here. And we're going to go back to SQLite in memory here, and we're going to change that so that we're pointing to a local file. So you can just add that SDK URI here, and we're going to go to the downloads folder, and we're going to take a path to that file. And just going to place that here. You see that I downloaded it multiple times, so we can use the first one. And we're going to rebuild this. So we can see here that we're on the 180 here, and we're going to be rebuilding this and see if it works properly. So if it does not, that means that it's not a runtime issue and it's something else. Okay, so that's not a runtime issue. So maybe we can go back 1 version, maybe. Let's see if another version of the runtime may help. So go back to this one. Maybe it's something that was changed in the runtime previously. Let's go for this one. Okay. There it is. And let's take this one and try to build it again. See how far we went. So I downloaded it already, so it's why I have another name. So let's build it. Just want to make sure that I'm using the right one. Just going to be rebuilding properly because Not sure if it's using the right one. Okay, yes it is. Okay. So there's definitely something that doesn't work there, and it's supposed to be working properly. So we're going to be having to troubleshoot that at some time again, but let's go back to the SkiaSharp Fiddle to do something different. Okay, so what we need here is a to avoid from the SkiaSharp Fiddle to download large set of files, is to make sure that we're downloading just one single. We're not downloading all the files at once. So if I take a look at my main package, you can see that it's 16 megabytes, which is pretty large. So I want to bring that down to something that's more acceptable in terms of size. So what we're going to do is basically generate a file that we know of, that will be part of there will be a content file that will contain all the list of all files that are available in that folder. So there's multiple ways to do that, but let's do it this way. We're going to do something like this. So we're going to make a target that's called build SDK files list. And we're going to take all the files that are in that folder. So we're going to make an item group. We're going to call that SDK my .NET SDK files. And we're going to include all the files that are in the .NET-SDK folder. And then afterwards, we can write something like this, which is, I think it's write lines to file. And then we can do file, and that file is going to be named .NET SDK-files list.txt. And the content is going to be lines with the files themselves. So it's going to be my .NET files there. And we're going to create that file before the build, so that we get that file created in that folder. What we also need is to change the embedded resources and put them. Hey Johnny, thanks. Yeah, yeah, it's quite amazing and quite interesting to work on that. So I hope you're enjoying it. So let's move to content. So those files are going to be packaged as part of the website content, but not as embedded resources. So that's a good one. And we're going to be adding also our file here that's called file list.txt. So file list.txt as well. So let's build this and see if the file is created properly. It should be. If we did it the right way. Okay, so it says failed to copy from one to the other. Okay, so that's because the build didn't. So that's because the file was not generated properly. Could be because this was not executed. So that's one of the things that the build logging here is able to help with. So if I build this, okay, I rebuild this actually. Is my file getting generated properly? So it looks like it's not. So let's see if in our build logging we have the target that we need here. So it's a build SDK files list. And I have that there. So it's not there at all. So it's not executed completely. So build is probably not the right one. So let's say maybe before build, there's another target that we can use. Okay, so my files list is available here and it has the right paths. So .NET SDK and all the files there. So it's all the files that are available here, and I need to get that. So the reason I need that file is that there's no, for this API here, the Windows storage, there's no file listing API. So you need to know ahead of time what you want to read. So that's why we're creating a file that's called files list, so we know that we can get all those files and then download them properly to populate the whole content properly. So that's one of the things that we can do. Okay, so that's the first one, and then what we can do now is change the compiler here to not use the manifest resources. Now we're going to be using something else. So what I see here is that we need to be able to be async. So we're in the constructor, so that's not good. So we're going to have to move this to an async method. Let's do this. Void initialize, and we're going to do async task actually, and let's move all this in here. Visual Studio is not happy with me today. Okay, there it is. Okay, so there's my task initialize, system threading, and so that one is read-only for a good reason. Okay, so what we need to do now is go and get the file list here. So let's do this. So I need to get that file. So that file is actually called .NET -sdk/files list.txt. And then, so I got that file. So it's a storage file. And then I can use file.fileio. something. So let's see. I think there's a read line available there. Okay, so still no IntelliSense for some reason. So let's go to definition. So there's readlines async, which returns an iList of string. So we can do readline file, and we call that files SDK files. Okay, so we have that. So that we download the file, we download the files list, then we get the files, and then we can build our list of files from the file list that we've built here. So that we can remove. And then in here we have a list of string, and then I don't know if we can do it that way because of the fact that it's going to be an async select. So let's not do it that way for now. Let's do a simple for each loop for now. So this is an enumerable. So we're going to make a list. A list of references, a list of metadata references, let's go at list for now, and we got the list of metadata references, and then we're going to just for each on each SDK file. SDK files. Okay, and then we can do the same thing as we did before. So except this time we're going to be building the URI differently. So it's going to be, let's remove this because we don't need it. And okay, and SDK file name. I'm just going to SDK file name. That's an SDK file, and then here we're going to compose the string. So we can just do something like this, And instead of that path, just use the one that comes from the SDK file name here. There we go. So that now we have that file, and then what we need to do is get a stream that we can pass it to, that we can pass to the reference here. So it's going to be list dot add here with the reference, and then yeah. So we can compose the tasks. We can await all tasks at the end. Actually, let's do that. So when I try to not do that too much, especially with regards to remote resources, because of the fact that it may just create too many requests at the same time, depending on the task scheduler. But let's try it. Let's try it that way to see if it actually works properly when working with WebAssembly. It should be, but who knows? Maybe there's going to be something that's going to be of interest. Okay, so we need to do, so let's remove that for now. Let's see if it actually does what we think it should be doing. So SDK file, we have the files here. We can select, and then we're going to be doing a when all at the end. So it's files task. Well, files tasks. It's a list of files with tasks. Let's do it that way. So we need to not await for that, but yeah, we need to await for it. Yeah, we need to await for it. So if we need to await, then this needs to be async. So we need to use continue with afterwards. Not a fan of continue with there. So let's do it. Let's do it just for one. Let's do it using a for loop for now. We can see if we can optimize that afterwards. But that's a good thing. It would be a task that we do at the end. We could probably do that with. Let's try it. So it would be a local function. If we do a local function, then we can return the task of that local function as part of the select. That could be. So let's try it that way. So that would be a task of metadata reference, and that would be load reference. And in there would be doing SDK file here, and then return the metadata reference. So we need to open the file. So that would be, I don't know if the IntelliSense is not going to help us there. So let's go to the definition for now. If the navigation is helping. Nope, no navigation to definition. Okay. Okay, so let's go and find that one out somewhere else. If we do storage file, let's search storage file as stream. Oh, no, maybe not that one. Something else. There's a documentation for storage file there. Oh, there's even a block from Martin Zikman. Well, let's go and take a look at Martin Zikman's. So we got storage file open string for write async or read async. So let's do that one, for instance. So that's a file. So we can, that's in storage folder. That's so maybe. Nope, doesn't want to. Okay, so let's go back here. So let's storage file. So storage file we got open somewhere. Open async, open read async. So open read async is going to be good enough. And then Yeah, well, I still need to await this. So interesting. So you're saying that it's probably too easier to add all the tasks into a list without awaiting the storage files. Yes, that's true. But the thing is that I still need to await then. I still need to await the read. So that what we can do here is probably just return that task, and I agree there. So we can do something like that. Return load reference. So that is going to be an array of tasks, and then once we're there, we can do task. Then I think it's when all. If I remember correctly, is when all. Yeah, it's difficult there. Visual Studio without that IntelliSense is a bit more difficult knowing all of that. So when all, so that returns when all. Okay, so that's the enumerable. We can have an enumerable. So let's do this. We can do tasks, and then it's an array that's returned, and we can put that array into references there. That should be enough. So we have this. The compiler's not helping there. It's probably saying something else. SDK file. So we're loading F. That's the file. We're reading it, and then stream here. I think there's a stream, if I remember correctly. Well, TrueStream. I never remember which one that is. So there's a way to convert from one to the other. So yeah, that's AStream. So let's try that one out and see what that does. So we have to invoke the initialize as well. So initialize is going to be done. So this method is not async. We have to make it async. There it is. And the C# language instance here has to be initialized. So this one's private. So if we can probably do something like that. So we're going to be initializing it every time, but if references is not null, then we bail out. For now. There's that, because that's the static that's initialized here. So we need to initialize it as a task. So let's do it here. So we have source language here and initialize it. It's pretty terrible. I don't know if it's that project that makes so much trouble, but I wonder if I unload this one, if it behaves better. Let's see. Okay, so source language and initialize, and we await for that one. Okay, so that's that. What was the error there? I don't know what that is. Let's build it to see where that goes. Okay. Okay, so non-nullable, unable to convert type from one to the other. So what's that? So an array of metadata reference to a metadata reference enumerable. Okay. So that would be that line. Okay, so we can probably just use it. So it wasn't enumerable, but it doesn't need to be. So we can use that one directly. So typecasting is not helping that much. Oh, we need to await it. That's what I was missing. So there it is, and that's probably it, I think. And that looks a lot better. So what now? Get exported types requests something. Okay, so that we need to await. So I'm going to do something that I don't like to do, which is put async in front for now, async void. So this is a big problem. So actually, we're not going to do it that way. We're gonna do it differently to make sure that it's called properly. So one of the reasons to not call async void is that you don't know where the outcome goes. So when something doesn't work, it may end up being on the thread pool, and then your application just goes away, which is not particularly good. So you don't want to have that compile your application crashing and just bail out without a good reason. So that's why you don't want to use async void that much. The thing is that because it's on the dispatcher, you're pretty much sure that it's going to come back to the dispatcher. So the best way is to use run async instead, so that you're sure that your input is going to be executed on the dispatcher probably. So, but for now, we're going to use async void so that it's easier for the demo. We're going to change that for next time. I don't know what's happening with Visual Studio. It's just so slow. Wow. Okay, let's close it for now. Let's see if I restart it, if it's better. Oh, it started the build. Interesting. Okay. Okay. Let's start it again. Maybe I heard reports of problems related to the use of if there's only UWP and one other project, sometimes it does weird things with IntelliSense. That could be the repro. So probably going to open a report for that on Microsoft. So so that it works properly. Then let's see. So one question, do you test the Linux platform bare metal Linux when running with VS Code? SDK GTK project, the newest template bare metal Manjaro Linux isn't working at all. In my case with VS Code and Net5. What do you mean not working? So best way is open an issue with the errors that you're having. To make sure that we're seeing the right thing and the kind of errors we're testing mainly on Ubuntu and Debian and others close, but maybe we've missed something that doesn't work on your case. So or maybe it's something specific to Manjaro. So let us know. Open an issue and we'll try to see if someone knows about it and if we can fix something in the templates. Another question, is the dispatcher using pthreads multi-threading in WASM? Is it already working in Net6? No, it's not working in Net6. And yes, it will use pthreads when available. It used to work somehow when running in under Mono directly, so not Net6, so not .NET 6. But it was something that was a kind of a proof of concept, so there were many caveats when using it. But when it will ultimately work, it's going to be using pthreads, and that's what the Nscripten library is using. It's using pthreads to provide threading support. But it's there's quite a few things that make it difficult to work with when running with threading. So namely, for instance, if you want to go back to the main thread, for now it's very difficult to do with Nscripten. There's no way to go back to the main thread without hacking around. So just so you know, it's something that to be on the lookout for. And then there's also the fact that because it wasn't tested that much, that means that there's a few things that are not working properly, like I remember that in some cases, some types of Lambda would just fail randomly because of the way the runtime is handling threading. So there's an open issue in .NET tracking this, but I don't know the latest state. I don't know if it's going to be part of .NET 6 at all, to be honest. So let's wait and see. Okay, so we should be good to be able to test that. So that's pretty good. So that built properly. So we have that. We have the uncompiled. Probably should be have added. So no, it's still not there. So code length reference is still failing for some reason. Code analysis, invoke core, JSON stream RPC, CLR Watson exception info. It looks like, oh, this is Watson failing. Interesting. So it's an error that errors out. Okay. That's interesting. So we have here the non-nullable references. Okay, so it may be null, so that's why it has to be tested properly. Okay, so what we're going to be testing out now is to determine if we're downloading the files properly. So we're recording the network, and let's see if we're downloading files. And yes, we're downloading files. So that's very nice. We got the Uno assets file. We got the files list here with all the content we had there. And all the files that we had in the folder are now downloaded locally so that the application can use them. But it still fails. So that means that there's probably something else that we didn't do correctly. Okay, so let's take a look. So maybe there was an exception somewhere that that failed for the loading for some reason. So because it's an async task and there's nothing that bubbles up the exception there, we're probably not seeing anything. So there's a compilation here. So we're saying here, so it could be failing another way. So let's do some try catch before. So the reason for that is that since we're an exception, we're probably not raising the files properly. So it's probably not the right way to do it. Let's go back a little bit. So it looks like we're missing. We need to add something to the UI so that we visualize the errors. But let's do it that way for now. Okay. Just gonna put it to the console for now. I think I'm gonna raise that that issue to Microsoft. This is pretty annoying. Okay. It still ends up working if I cancel the content, but anyways. Okay, so let's start it again. So Gromovnix, sorry if I messing it up. You found out about Uno a few days back. For me, as a C# dev, it will explore for the run. Yes. Well, let us know. Let us know how that goes, and if it's helping you, you're building Grum, that works. Okay, that I can say. Let us know how your experimentation is going. And that's it's all about all those streams, and experimenting live like this is about showing all the quirks and all the things that we can fix and show you how to debug and troubleshoot what's happening in Uno. Okay, so still building. Let's take a look at what's happening there. So it's Ninja that's running. So Ninja is running, and it's doing what? It's running the linker. Okay, so that's probably something that I'm going to be changing for next week's stream, because I don't want to have to wait for the linker in between. It's probably not that useful. And having you wait for for the compiler to work during the stream is not something that's particularly interesting. So and in that case, the linker is doing too much work for not for nothing, but it's not particularly useful. So we can remove that next time, and it's something that we're gonna be having to adjust the bootstrapper so that we can remove the content that's not needed. Okay, so let's take a look again. We compile, what happens? Okay, it fails. Okay, the file PDB cannot be found. Oh, yes. That's a good one. Okay, so that's a good reason. So the reason for this is that the files list is too aggressive. And there's PDBs in that list. It's probably at the bottom, I guess. Yes, there are PDBs there, and we don't want PDBs. They're not, and they're actually excluded from the other content. So we can remove that from there, and let's just take a look at the DLL files instead. Of course, for now we're not going to be debugging anything that comes from those assemblies because they're not available, but. Okay, and let's see if that works. And if that works, it's going to be a wrap. That's going to be a good. It will have been a good stream. And for that one, that means that we're going to be having to take a look at something different. Probably it could be that the files are different, or the files, the copied files are incorrect. So for instance, if I use the same. If I use the same runtime and that the assemblies inside are not the same, that could mean that the algorithms that do select the files that need to be in the this folder is not the right one. So it could be that the files in that managed folder are not the right one, and that I need to change the optimization that I made to make the bootstrapper go faster. So that's going to be one of the change that I'll need to make for next week as well. Okay. So one thing is interesting here, and let's go take a look at the Ubuntu again. We can see here that the linker is running. So let's make it even bigger. So we can see here it's running the IO linker, so that's the equivalent of that here. But what's of interest is that the size. The actual memory size of the linker is pretty large. It's we're talking 1 GB of committed memory, which is of actual memory, which is pretty large. I would have assumed that it would have been a bit smaller, but yeah. So is it building? No, it's not. So what again? Okay, the file cannot be found. Okay, so maybe it would mean that the file here was not updated properly. Okay, we still have PDBs there. So it could be that the list is not updated properly. Maybe the file is not overwritten. Overwrite. Ah, there we go. So the file is not overwritten. So let's build again. Always small parameters here that you need to add, and by default it's not showing up. So that would be something that I would have seen in the build login tooling, where the file would have been just skipped because it was existing already. So we can take a look at the file again and see if there are PDBs. So let's reload it. No more PDBs. Good. So no more Sybil file. So it's going to load up properly, and we should be good to go. So still the linker running again, and same type of parameters. So let's see if I see the same thing. Oh, that's interesting. That's a quite large number. .48 gigabytes. That's probably something like .NET behaving differently when running in WSL. So the 800 and 880 is matching with, closely matching to that one, probably. So that's pretty close. 1 gig. 1. Okay, that's close. Okay, the numbers are matching, which is quite interesting. Okay, so that's good. Okay, we're done. Almost. There it is. So having the linker running is not good for also for a good inner loop. So taking it out is going to be a lot better. Got compilation and it failed. It failed for some other reason. Type name SkiaSharp could not be found. So that would be something else. Could be maybe files that we have not added properly. Object does not contain the constructor there. So it could be that we're not loading everything up and it doesn't work properly. So we're going to have to find that one out, but that will be for next week. So that would mean that there are some files that are not loaded up properly in that list, or let's say file list here. So let's say SkiaSharp. Yeah, SkiaSharp is here, so it should have been loaded. Could be maybe the backslash. The backslash is forwarded properly because the files are loaded up properly. Let's see if I take a look again. Oh, not modified. Yeah, the files are not modified. So maybe we're missing something else. Okay, so that's something that we're probably going to be taking a look at. So I'm going to be cleaning up the local storage of the application to ensure that we're having the right thing. Let's see. So that's something that we need to take a look at to ensure that the files are behaving, the local files are behaving properly. So see, it reveals the fact that there's a file that was loaded up and that's probably not the right one. So it's probably doing something incorrect there. Yeah, no, it's doing something else. So in memory could not be open. P image does not contain managed metadata. Okay. Okay, so not good. That means that there's something that we're doing here that is not behaving properly. So the loading up of the files there that we're doing here is not working properly. The loading up here is not working properly. So maybe the stream is referenced and not copied or something like that. So maybe we need to copy it to memory stream so that it keeps that it stays up. So we don't know who's managing that. So let's take a look at that. Maybe I'll have fixed it for next week, but maybe not. So thank you for staying 20 minutes longer. Generally do it for 1 hour, but that one got me carried away. So pretty good. So thanks for listening, and give me a follow if you haven't already. And I'll see you next week. Bye.